front row.
Hi, thank you. I just wanted to ask if you had done any research on the genetics associated with faith.
With?
Faith, belief systems.
Faith, right. No, I haven't.
The reason I ask is because I've seen articles recently coming out on that, and I can imagine that's quite explosive as well.
Do you know, I do a lot of public events. I talk about genetics a lot in public, and I'm always surprised when there's a question I haven't heard before. And that was one of them.
But that came up at your talk.
Did it?
Yeah, your Royal Institution talk, yeah. Guy over here asked you about how does it relate to faith.
I got a very short-term memory.
No, but you know,
Thank you,
there is quite a bit of research on attitudes and interests and that sort of thing. It depends what you mean by faith. And I published a paper. I'm always looking for something that isn't heritable, because to my knowledge, there's no trait reliably measured in psychology that does not show significant genetic influence. So once I tried early on, I found kindness. I always thought, as a parent, I value kindness. I thought, this can't be very heritable, and I did a study, and it seemed to be less heritable. Well, so I made a big deal about that. Every study that's come out since says it's just as heritable as every other aspect of personality. The second time I tried to do that was with religious, how much do you believe in God? That religious, what is that? The faith?
Religiosity.
Religiosity, exactly right. And said, well, that doesn't seem to be as heritable, and mostly due to nurture. Every study since shows it's just as heritable as everything else. All attitudes seem to show this genetic component.
It's not a bad example, actually, because in that, if religiosity is heritable, the nature of that religiosity presumably is much less so. I mean, whether you turn out to be a Catholic or a Muslim is entirely dependent.
So religious acts are not very heritable.
Yeah.
Do you go to church on Sunday? But we better move on, huh?
Yeah, sure.
I may have misunderstood, but you've referred several times to a figure of 50%. 50% heritable. And I didn't understand where that figure came from.
Okay, so this is heritability 101. Let's do this.
Okay. The easiest way to understand it probably is if you think of an adoption design. So if you think of birth parents and their adopted away children, they share 50% of their genes. They're only 50% similar genetically. But say in terms of general cognitive ability, AKA intelligence, they correlate about 0.25. So that's an estimate of half of the genetic influence. You get to 50%. If you compare identical and non-identical twins, say for IQ, the correlation is about 0.85 and 0.5. That's an index of half of the heritability because non-identical twins are 50% similar genetically. So you can double the difference in their correlations and estimate heritability. So there's about a dozen different ways to do this, most recently using DNA alone. But all of those estimates converge on the conclusion that heritability, that is, inherited DNA differences, explain about half of the differences that we see for these traits. And this is explained in detail in the second chapter of the book, even though I hesitate to put it in because it's so boring, but it is so fundamentally important that people understand we're talking about variance. People don't get variance. We think of groups and differences between males and females. We don't think about individual differences, variance. So it's hard to think about heritability because we all learn about genetics from Mendel, which is a single gene, hardwired, deterministic thing. If you have the gene for Huntington's disease, you will die from Huntington's. It doesn't matter what your environment is. But when we're talking about thousands, actually tens of thousands of tiny DNA differences, these polygenic scores, putting all of those little risks together, are probabilistic. They're not deterministic.
And this is something I've written a lot about in my last book. Huntington's is a really good example, but to mention Mendel and the other classic diseases that were the beginning of us understanding the genetics of disease and other traits, the whole history of our field points towards us trying to identify single genes that have a deterministic function. And why the DNA revolution is so significant is because it looks like they're the outliers, right? And they're the ones that we discover first because Mendel was looking at peas. Turns out we're more complicated than peas. But the first disease genes that we identify are the ones that run in families in very, very clearly segregated ways, like cystic fibrosis and Huntington's and Duchenne muscular dystrophy. But even cystic fibrosis turns out to be a good example to show the environmental influence, because even though 3/4 of people in the West with cystic fibrosis have exactly the same genetic difference, the severity, the penetrance of their disease is hugely variable. And just last year, 15 genes were identified that had a significant effect to the penetrance of cystic fibrosis. So even for those classic monogenic, sort of deterministic genes, it turns out there's tons more heritability in the genome that we haven't even identified yet.
Yeah, it's well said, yeah.
Okay,
Good point.
Sorry, it was a little bit of a lecture from me there. I think it was this lady here next.
Hello. I'm interested in whether heritability changes with age, because there is the idea that we inevitably become our parents, but we don't necessarily, as children or young adults, act in the same way as our parents. So does it change over time?
Terrific question.
Yeah, very good question. Heritability is a descriptive statistic of a particular population and a particular age. So heritability could differ at different ages. If you ask people, if we had time to do a survey here, most of you, if you understood what we said about heritability, most of you would say that heritability decreases over time. Because people would say, because environments, accidents, slings and arrows of outrageous fortune increase as you grow up. And we think of genetics as what happens to you at the moment of conception. Well, both of those concepts are wrong. Genetic effects have different effects throughout the lifespan. So the simple answer to your question is, with IQ, we find that heritability increases sharply throughout development, from 20% in infancy, 40% in childhood, 60% in middle adulthood, and some people say 80% in old age minus dementia, if you exclude dementia. So that's a huge increase in the extent to which genetics becomes important. And you said about resembling your parents more as you get older, and that's the way the genetics seems to go, that the older we get, the more we become who we are.
Which is an uplifting or depressing thought, depending on how you look at it. And you mentioned IQ just then. I want us to take this opportunity to just say something about IQ, because I talk about intelligence and inheritance and heritability. And sometimes a sort of cultural meme that gets said often is, well, IQ is just a measure of how good you are at IQ tests. Now, this is something that, it's the second thing you take away from this talk, other than understanding heritability and the book, is just justify IQ as a metric, because it's really important, this.
Well, learning ability is very important. And Spearman invented this construct of general learning ability in 1904. And because of the problem you raised earlier about all the connotations that go with intelligence, he said, no, let's give it a special name, call it G for general cognitive ability, and it is what I mean by it, and that is what different tests have in common. So all of you think you're either good at math or good at verbal and not so good at other things. Actually, if you're good at one thing, you're pretty good at other things. Maybe you're a little better at one thing than another. That's where G comes in, the idea that all these cognitive tests, from memory to verbal ability to spatial ability, processing speed, they all correlate about 0.3 or so. And G is what they have in common. And so it's a statistical artifact in a construct, but it's an important one because it predicts more things in society than just about anything else. It predicts how well you do at school because it's learning ability. It's not to say it's all G. There are specific abilities that are really interesting, and the DNA revolution has only hit G so far. What'll be really interesting is to do these sorts of genome-wide studies for specific abilities, because there are specific genetic effects. But G is very stable throughout the lifespan. In a correlation of 0.7, that explains, say, 50% of the variance. So it's not a constant at all. But to dismiss it by saying, oh, well, it's just what intelligence tests measure. What I often say to my classes is, if you get bored at a dinner party some night, just construct an intelligence test. Just say, what do you mean by intelligence? And quickly people will say, I don't mean university challenge type intelligence. That's
really
kind of a
that.
crystallized, yeah, exactly. Well, I'm not good at it either. But you'd agree, it has to do with abstract reasoning, solving problems. You come up with a new problem and you solve the problem. So it's not a matter of memorized stuff as much as dealing with the problems that we were faced evolutionarily, which is why I think that G involves the whole brain, which makes sense. If there are thousands and thousands of genes, the neuroscientists looking for modular approaches, like this bit of the brain does that. It just seems to me the brain had to evolve as a general problem solver, using whatever little help it can get throughout the brain.
Yeah, Anil Seth, who's a cognitive neuroscientist, says that intelligence is a terribly poorly defined thing anyway, and the best way that he's found to describe it is doing the right thing at the right time. Let's have another question.
We increasingly see the importance of DNA and genes in our behavior and who we are and our behavior and the decisions that we make. So do we actually have free will at the end of the day, and how can people be held accountable for behaviors that are influenced by their genes more than nurture or their environment?
Could you rephrase? I didn't quite catch some of the words.
I think the key idea was, do we have free will?
Would
You only get this at the Royal Institution, So if genetics is a big part of
it's
our
really
entire
important.
behavior.
It's why I, whenever people say determine or any of these fatalistic words, I say no. We're talking about probabilistic propensities, nudges. So what I didn't get to say, and it's a good chance to do it, is my polygenic score for weight is at the 94th percentile. Now my actual weight, as you can see, is portly, 70th percentile.
Do explain what polygenic scores for the audience, please.
Okay, that's the idea that any one of these SNP associations that we talked about accounts for so little variance, it's not of any use. But you can aggregate them together like you do items on a test. You don't ask one question on an intelligence test or personality test. You ask a lot of them and you put them together, because together then they tap into this construct and become predictive. So a polygenic score involves putting together a lot of these SNPs. And what's changed in the last 2 years is a lot isn't 1,000 and it isn't 10,000. It can be 100,000. Tiny DNA differences. But then you use those to predict in an independent population. And these work. So with the polygenic score for weight, we can explain maybe 8 or 9% of the variance in weight. Well, my polygenic score is very high, 94th percentile. Does that mean I've lost my free will? I got to just say, I'm a genetic fatty, nothing I can do about it. To the contrary, it makes the point, for me, it's been very motivating. I've always had trouble with weight. I put it on easily, it's hard to get rid of it. But now, it kind of makes sense to me that actually, I deserve credit. I'm only at the 70th percentile for weight when my polygenic score is at the 94th percentile. But it's actually motivating because you can obviously do things about it. If you want to lose weight. If I stopped eating, I'd lose more weight. But I know I've got to organize my environment to take care of this problem that I have, and that is if there's rich foods around, I'll just eat them.
Okay, so let's. We're in one of the.
There's no food here, but
no, I know. I'm really hungry as well.
Me too.
Is someone get us a burger? One of the offshoots of the DNA revolution is that now that DNA tests are available to everyone, to punters, not just that scientists have access to DNA in unprecedented ways, but that you guys can pay £100 or so and spit in a tube and you get back primarily they tend to be ancestry-related ideas, but I did 23andMe and it puts me in the high risk, doubles my probability of getting Alzheimer's by the time that I'm 80, right?
You have one allele then.
One, yeah.
If you had two, it would be 80%, right?
Right. Now, that is, I understand this. This is something that I can do nothing about.
Mm-hmm.
So what do you think about this? The access that we have to this code that for the last 4 billion years has been inaccessible to us.
Yeah, it's a great question, and a lot of the concern that comes up about direct-to-consumer testing, like 23andMe that Adam just described, is the fact that it's not supported. If you had found out you had I had a reporter in my office, the thing in the Spectator a couple weeks ago, Katie Laws, she wanted to open her results it live with me, right? And I thought, well, I'm kind of uncomfortable with this because she had a grandmother who died of Alzheimer's, and fortunately, she also has a sister with breast cancer. She didn't have any of those genetic risks, which was tremendous. But this is powerful stuff, I agree. But a lot of the concerns are about the Wild West. Some of these are not very reliable. And what I want to get a pitch in here is to say, I think we need to have the NHS do this. And I know people will be appalled at that, but it's going to happen. Just last month, there was a paper in Nature Genetics. You can predict cardiovascular risk. There's 8% of the population that have a 3-fold greater risk of a heart attack just based on DNA alone for the polygenic score for cardiovascular risk. Francis Collins, the head of the National Institutes of Health and the former director of the Human Genome Project, says that looking back on this a few years from now, we'll say it was unethical we didn't do this. Now, I know there's all the concerns about, data security and that sort of thing, but you do it once, you pay your 100 quid, or if we do it for in these large projects now, it's down to about 30 pounds or something. You do it once, end of story, that's it. You can predict all these polygenic scores with that information. So if your doctor knew that you were at this much greater risk, and this is 8% of the population, these single genes that people talk about, they're like 1 in 10,000, 1 in 100,000. Here's 8% of the population at 3-fold greater risk of having a heart attack. How can you not tell them? Because there are things you can do about it. Alzheimer's tough because people say nothing you can do about it. And so why would you want to know? Well, it's interesting because I found like Katie Laws and me, of course you want to know, I would say. But people really divide on that. Yeah. And because I think I can do something about it. I can plan my life for that. I can get financial and social security to take care of myself. Sure, but and I can live more carpe diem.
Well, that's definitely true. But I think what's interesting is the sense that, the powerlessness of, it sort of relates to your question about free will, that it is probabilistic, and most people who have that particular gene mutation don't get Alzheimer's because that's the probabilistic nature of genetics. But I think that part of the discussion and part of the reason that that we sometimes talk about to try to downplay the influence of genetics is that there's no health advice you can give in that scenario which isn't absolutely bog standard, which is don't smoke, do as much exercise as you can, eat well, and have a strong social network. So in that case, I've got a genetic propensity to getting Alzheimer's. And during the course of this talk, I think it might have hit onset early. But there's nothing I can do about it other than bog standard dietary lifestyle advice.
Yep, but all of medicine is moving towards prevention, and DNA is the best predictor we have. So to prevent, you got to predict, and you can predict with DNA. So I think that makes it much more likely that we'll be able to come up with interventions that work, some of which will be more specific than the general bromide of eating well and exercising and that sort of thing. But it isn't nothing. We're all told, say alcoholism. We don't have a good polygenic score for alcoholism, but we will. And when we do, you don't become alcoholic unless you drink a lot of alcohol. So if you knew that you or your kids were at, say, a 10-fold greater risk of becoming alcoholic, there's a simple solution. It's the same one we all get. Take holidays from alcohol, make sure you're not too dependent on it. Just monitor your alcohol use, because if you drink as much as other people, they don't become alcoholic, you're at risk for becoming alcoholic. Sure. So a lot of the interventions are going to be low tech. Just because it's genetic doesn't mean that we have to administer drugs or do a biological intervention. Yeah. So I'm very excited about this. And I know we're running out of time, but the NHS, we've got to be so happy we have an NHS because we can spread out these genetic risks. What are you going to do if you're in the United States and you have a money-based, insurance-driven system? I don't see how it's going to work, because if the insurance company finds out you're at high cardiovascular risk genetically, they're going to do their best not to insure you. It makes sense to them commercially. Unless you have a national system that can distribute the risk, I don't see how they're going to handle the DNA revolution.
And yet there are no necessary policy implications.
You're absolutely right.
Well, look, the bell went, which means it's 9 o'clock, and I'm sorry that I didn't get more questions in, but we can do this all night. But Robert's going to be, the book is available outside, and he's going to be signing. I'm sure we'll take some of your questions, which end with an upwards inflection, and you're allowed one per person, because there'll be a long queue. But all that remains is for me to ask you to thank Professor Robert Plomin.
And Adam.